Good morning, ma'am. Good morning to everyone. My name is Leela Kalyani. I am from CSC department. Today I am telling about the topic from the subject Digital Logic and Computer Organization. Today my topic is about the multiprocessor and the multi-computer systems. Here is the next slide about the topic name, multiprocessor and a multi-computer system. Here is about the introduction to a multiprocessor and a multi-computer system. Multiprocessor multiple computer system consists of survival independent computers connected via a network. They work together to perform complex tasks by sharing resources and a workload. These systems are widely used in a high-performance computing and distributed applications. Here is the diagram of the multi-computer by message passing network from processor 3 memory to from processor 4 memory and processor 1 memory to from processor 2 memory. Next slide is the architecture of the multi-computer system. The architecture involves multi-autonomous computer linked through communication networks. Each code has its own memory, processor and output and input devices operating independently. Communication between nodes is achieved through message passing or shared memory protocols. Here is the diagram of the same multi-computer system. Next slide is about the types of multi-computer system. Multi-computers can be classified into loosely coupled and tightly coupled system. Loosely coupled system have a minimal hardware sharing suitable for distributed application. Tightly coupled systems are interconnected with a high-speed links often used in a parallel commuting. Next slide is about the communication mechanism. Message passing in the primary communication method between processor in a multi-computer. Communication latency and a bandwidth significantly impact system processor. Efficient communication protocols are critical for ensuring data consistency and synchronization. Message passing multiprocessor. Multi-computers communication is based on message passing between processor and not shared memory access. Can all records methods removal producer call. Involves MI2 message passing interference. Synchronized communication causes process synchronization. Address space allocated private address to each other to distant processor. Example, massive parallel processing. Next slide is about the advantages of a multi-computer systems. They offer scalability, allowing systems to grow by adding more nodes. Multi-computer systems provide fault tolerance to the distributed processing. They are cost-effective compared to large monolithic supercomputers. Next slide is about the challenges in a multi-computer system. Managing communication overhead can be complex and affect system processor. Synchronization among nodes is challenging and essential for correctancy. Software development for such systems requires specialized programming models and tools. Next slide is about the types of multi-computer system. Multi-computer system can be classified into loosely coupled and tightly coupled systems. Loosely coupled systems have a minimal hardware sharing suitable for distributed application. Tightly coupled systems are interconnected with a high-speed links often used in a parallel computer. Here is the diagram of the multi-computer system message passing network. Processor 3 memory to processor 4 memory, processor 1 memory to processor 2 memory. Next slide is about the challenges in a multi-computer system. Managing communication overhead can be complex and affect system processor. Synchronization among nodes is challenging and essential for correctancy. Software development for such system requires specialized programming models and tools. Here is the multi-computer same diagram represented from the above slide. Here is the message processing network. Processor 3 memory to processor 4 memory, processor 1 memory to processor 2 memory. Next slide is about the applications of a multi-computer system used extensively in a scientific simulations and a large-scale data processing, suitable for a real-time processing in a telecommunications and imaging systems employed in a cloud computing environments for scalable resource management. Here is also same diagram represented from the above slide. Next slide is about the performance factor. System performance depends on a network speed, processor speed, and memory access times. Load balancing is useful to ensure even distribution of a task across nodes. Efficient algorithm for the communication and computing can significantly enhance performance. Here is the diagram of the interconnect. Next slide is about the future trends in multiprocessing system, integration with the cloud community and visualization to enhance flexibility, development of intelligent routing and adaptive communication protocols, increasing use of heterogeneous processor including GPS and specialized RAs. Here is a diagram of the top cloud computing trends for 2023. It is a summary and communication. Multiprocessing systems are essential for a high performance and distributed computing. They offer scalability, flexibility, and cost advantage, but possess unique challenges. Ongoing advantages aim to improve their performance, reliability, and application scope. Next slide is about the reference. Stallings.w 2024 Computer Organization and Architecture. Next, Tannenbaum.ac. and Van Steen M 2007 Distributed Systems Principles and Paradigms Presence Hall. Next, Colliers.g and Dolimo.j and Kinbridge.e at 2012 Distributed Systems and Persons. Thank you, ma'am, and thank you to all.